Your CI pipeline is already an AI agent platform. You just don't know it yet.
Wait, are you saying we don't need LangChain or AutoGPT anymore? So we're covering how Cicaddy turns CI into agents, the multi-turn reasoning piece, and actual production examples?
By minute 4, you'll see exactly how to ship agentic AI without a single new platform. Let's get into it.
Welcome to the AI Daily Podcast, today's news and a deep dive to help you stay ahead in AI.
Today, we're diving into how to develop agentic workflows in a CI pipeline with Cicaddy.
Stick around to the end for today's headlines. Let's dive right in.
So let's talk about something that's been quietly revolutionizing how engineering teams think about CI/CD pipelines. We're seeing this shift where teams are embedding AI agents directly into their existing CI infrastructure instead of spinning up separate AI platforms. And the framework that's making this possible is called Cicaddy.
Okay, I'm intrigued because every time I hear about agentic AI, it seems like you need this whole separate platform, new credentials, new runtime. It's a lot of overhead before you even get started.
Exactly, and that's the breakthrough here. The core insight is that your CI pipeline is already a perfect runtime for agentic workflows. Think about it. What does an AI agent need? It needs to schedule tasks, execute steps, pass context between stages, integrate with external services, and maintain an audit trail. Your CI system already does all of that.
But wait, when I think of agentic AI, I'm thinking of these long-running processes that can have conversations, make multiple decisions over time. How does that work in a CI pipeline that's typically more transactional?
Great question. And this is where the architecture gets really clever. Cicaddy uses what they call a one-shot execution with multi-turn reasoning model. So yes, from the CI perspective, it's a single job that runs and completes. But inside that job, the agent can perform dozens of reasoning steps using the react pattern. That's reasoning and acting combined.
So it's like the agent wakes up, figures out what it needs to do, gathers information from various sources, makes decisions, and then produces its output all within that single pipeline run.
Precisely. And here's what's fascinating. You're not replacing your existing workflows, you're extending them. All those deterministic steps you already trust, fetching data, calling your internal APIs, collecting logs, those stay exactly the same. The AI agent slots in where LLM reasoning adds value.
Give me a concrete example. What would this look like in practice?
Let's say you have a pipeline that runs on every pull request. Currently, it might run tests, check code coverage, maybe do some static analysis. With Cicaddy, you could add an agent step that reviews the code changes, analyzes test failures in context of recent commits, checks if similar issues have occurred before, and generates a comprehensive report with specific recommendations.
Oh, so instead of just getting a pass-fail from your CI, you're getting intelligent analysis about why something failed and what to do about it.
Exactly. And the beautiful part is that this agent can access all your existing tools through the Model Context Protocol. It can read local files, query your monitoring systems, check your documentation, all within that single pipeline execution.
But I'm thinking about the practical side here. How reliable is this? What happens when the LLM hallucinates or makes a bad decision?
That's the critical question every team asks. And it's why the design philosophy here is so important. You're not giving the agent direct control over your infrastructure. It's generating reports, analysis, and recommendations. The actual deployment decisions, the merge approvals, those still require human oversight. Think of it as augmenting your team's decision-making rather than replacing it.
Coming up, we'll dig into exactly how Cicaddy pulls this off technically, what the react pattern looks like in practice, and some real performance numbers from teams using this approach.
All right, let's dive deep into how Cicaddy actually works under the hood. The framework is built around 3 core stages: collect, reason, and act. In the collect phase, your pipeline gathers all the context the agent needs: logs, metrics, code changes, whatever's relevant to the task.
And this is just using standard CI pipeline steps? Like if I'm in GitLab CI or GitHub Actions, I'm just using regular job definitions?
Exactly. That's the beauty of it. Here's a real example. One team I talked to uses this for analyzing flaky tests. Their collect stage pulls the last 30 days of test results, identifies which tests have been failing intermittently, grabs the relevant code changes, and even pulls in any related issue tickets.
Okay, so now we have all this context. How does the reason phase work?
This is where Cicaddy really shines. It implements the react pattern, which stands for reasoning plus acting. The agent doesn't just make one inference call and done, it goes through multiple reasoning loops. Let me walk you through what actually happens.
Please do, because this is the part that seems almost magical to me.
So the agent starts with your goal. Let's say, analyze why this test suite is flaky and recommend fixes. It first reasons about what information it needs. It might think, I need to look at the test code, check when failure started, see if there are timing issues. Then it acts by using model context protocol tools to gather that information.
And these MCP tools, are those custom built for each team?
They can be, but there's a growing ecosystem. You've got tools for reading files, querying databases, calling APIs. One team built an MCP tool that interfaces with their Datadog metrics. Another has one that searches their Confluence documentation. The agent can use any of these during its reasoning process.
So it's like giving the agent a Swiss Army knife of capabilities.
Perfect analogy. And here's where it gets really interesting. After each action, the agent observes the results and reasons about what to do next. Maybe it discovers the test failures correlate with high database load, so it decides to investigate further, pulls metrics from the database monitoring, checks if there are connection pool issues.
But this could spiral out of control, right? What prevents the agent from just reasoning forever?
Great point. Cicaddy implements token budgets and time limits. Most teams set a budget of around 50,000 tokens per execution, which typically allows for 20 to 30 reasoning turns. If the agent hasn't completed its task by then, it summarizes what it's found and provides partial results.
What kind of performance are we talking? This must add significant time to pipeline execution.
The numbers are actually pretty reasonable. A typical agentic step adds 30 to 60 seconds to your pipeline, depending on the LLM you're using and the complexity of the reasoning. One team running this on every PR sees their average pipeline time go from 8 minutes to about 9 minutes. But the value they get, automated root cause analysis, intelligent test selection, even suggested fixes, more than makes up for it.
What about costs? LLM inference isn't cheap, especially if you're running this on every commit.
You're absolutely right to think about costs. Most teams are spending between $0.10 and $0.50 per pipeline run, depending on the model and task complexity. But here's the key. You don't run this on every single pipeline. Smart teams use it strategically. Failed builds, run the agent. Nightly regression tests, run the agent. Regular feature branch pushes, maybe skip it.
I'm also thinking about debugging. When something goes wrong, how do you figure out what the agent was thinking?
This is where Cicaddy really learned from early agentic frameworks. Every reasoning step is logged. You can see exactly what the agent observed, what it decided to do next, and why. It's like having a detailed thought process you can audit. Some teams even use this for compliance. They can show exactly how automated decisions were made.
That's crucial for building trust. Speaking of trust, what about prompt injection or security concerns?
Critical question. Cicaddy runs in your existing CI environment with your existing security controls. The agent only has access to what you explicitly give it through MCP tools. No direct shell access, no ability to modify code unless you specifically build a tool for that, and all prompts are parameterized to prevent injection attacks.
Stick around. In our final segment, we'll give you the exact checklist for implementing Cicaddy in your own pipelines and what to watch out for.
All right, let's get tactical. If you're thinking about implementing Cicaddy in your pipelines, here's your roadmap. First, start small. Pick one specific problem that requires analysis and reasoning. Flaky test analysis, performance regression detection, or automated code review summaries are great starting points.
Why those specific use cases?
Because they're high value but low risk. If the agent makes a mistake analyzing a flaky test,
no big deal. You've lost nothing. But when it correctly identifies that your tests fail every Tuesday at 2 p.m. because that's when the backup job runs and saturates the database, you've just saved hours of debugging time.
What about the technical setup? What do teams need to have in place?
3 things. First, you need an LLM provider, OpenAI, Anthropic, or even a self-hosted model if you have the infrastructure. Second, you need to containerize Cicaddy for your CI environment. The project provides Docker images for major CI platforms. Third, and this is crucial, you need to design your MCP tool suite carefully.
That last point seems like where teams could really get stuck.
You're absolutely right. Here's my advice. Start with read-only tools. File readers, API query tools, log aggregators. Get comfortable with the agent gathering and analyzing information before you even think about giving it write capabilities. One team told me they spent 3 months in read-only mode before they let their agent create Jira tickets.
What are the common pitfalls teams hit?
The biggest one is overambition. Teams try to build these complex, multi-stage workflows right away. Another is token management. They don't set proper budgets and get surprise bills. And the third is what I call agent sprawl. They start adding AI steps everywhere instead of being strategic about where it adds value.
How do you prevent that sprawl?
Simple rule. If a task is deterministic and works well today, leave it alone. AI agents excel at tasks that require context synthesis, pattern recognition, and adaptive reasoning. They're overkill for tasks like copy files from A to B or run this specific test suite.
How do teams' readiness fit in? This seems like it requires a different mindset.
Absolutely. The teams that succeed treat their AI agents like junior engineers. They give them clear goals, bounded responsibilities, and review their work. They also invest in prompt engineering skills. Your prompts become as important as your code, so version control them, test them, iterate on them.
Looking forward, where do you see this going?
I think we're heading toward a world where every CI pipeline has some level of intelligent reasoning built in, not replacing developers, but augmenting them. Imagine agents that can predict which tests are likely to fail based on code changes, automatically suggest performance optimizations, or even draft release notes by analyzing commits and issue closures.
But won't this make pipelines more fragile? More points of failure?
That's the fascinating paradox. In some ways, yes, you're adding complexity, but these agents can also make pipelines more resilient. They can adapt to unexpected conditions, route around problems, and provide context when things go wrong. It's like having a smart assistant who can say, hey, this build failed, but it looks similar to an issue from last week. Here's what fixed it then.
For teams listening who want to experiment, what's the minimum viable setup?
Start with a single GitHub action or GitLab CI job that runs Cicaddy on failed builds only. Give it read access to your logs and recent commits. Have it generate a failure analysis report. That's it. You can implement this in an afternoon and start seeing value immediately. From there, gradually expand based on what provides value to your team.
Any final thoughts on where this fits in the broader DevOps landscape?
I think Cicaddy represents a broader shift in how we think about automation. We're moving from deterministic workflows to adaptive ones. Your CI pipeline becomes not just an executor of predefined steps, but an intelligent system that can reason about what's happening and adjust accordingly. It's not about replacing human judgment, it's about augmenting it, freeing developers to focus on creative problem solving rather than routine analysis. And the beautiful part? It all runs in the infrastructure you already have and trust. Before we wrap up, let's catch up on this week's infrastructure news. There's a fascinating new development for anyone struggling to run large language models on consumer hardware. An open-source driver called GreenBoost is aiming to dramatically expand NVIDIA GPU memory by tapping into system RAM and even NVMe storage.
Wait, so you're telling me I could potentially run models that require way more VRAM than my GPU actually has?
Exactly. According to Phoronix, this could be a game changer for developers and researchers who want to work with larger LLMs but can't afford those expensive enterprise GPUs with massive VRAM.
Though I imagine there's got to be a performance hit when you're pulling from system RAM or storage instead of native VRAM.
True, but sometimes having the ability to run a model at all beats not being able to run it. Speaking of making AI more accessible, ChatGPT just rolled out some major app integrations that are pretty impressive.
Oh, I saw this on TechCrunch. You can now order DoorDash, control Spotify, and book Uber rides directly through ChatGPT?
Right. And it goes beyond just those. They've also integrated Angie for home services, Booking.com for travel, and Canva for design work. The process involves connecting your accounts and then just asking ChatGPT to handle tasks naturally in conversation.
That's moving us closer to that true AI assistant experience. Though speaking of AI agents, there's an interesting startup tackling one of their biggest limitations.
Nine, founded by a father-son team, just raised $5.3 million to build what they're calling an intelligence layer for AI agents. TechCrunch reports they're analyzing people's digital footprints across platforms to give AI agents the human context they desperately need.
That sounds powerful, but also raises some privacy questions. How much of our digital lives are we comfortable sharing with AI agents?
It's definitely a balance between functionality and privacy. On a lighter note, there's this interesting phenomenon with ChatGPT and Claude that Tom's Guide tested out, something called the glitch prompt.
Glitch prompt? That sounds like something from a sci-fi movie.
It's actually a specific prompt that supposedly makes these models more careful and precise in their responses. When Tom's Guide tested it on Claude, they found it led to more thoughtful, accurate answers with better reasoning.
So it's like a magic phrase that unlocks better AI performance? I'm definitely trying that later.
Worth experimenting with for sure. That wraps up today's news. That's our show for today.
If you found this valuable, please subscribe and share with a friend who'd appreciate it.
Drop us a comment with your thoughts on today's topic.
Links to everything we discussed are in the show notes.
Until next time.